Hello, everyone. I hope you can hear me, right? Uh-huh. And if you have any friends who are interested in artificial intelligence, please do invite them because I see a lot of empty spaces. Anyways, all of us who are here, we'll try to make maximum out of it. So I am Emad Ehsan. I am a Google developer expert, and I am also a senior software engineer at Bayer. And today we are talking about the latest in the large language models and how they are enabling the latest innovation in how we build our software. So the specific application that we are looking for today is related to building a search engine or a search bot that actually answers your questions from your data. And before we start, I would like to have a quick show of hands, those of you who are students and junior engineers, senior engineers. Awesome. So what is an LLM? Anybody would like to take a guess? And what do they do? Okay, so on a very basic level, large language models are autocomplete, very sophisticated autocomplete. So you give them a text of input, and they output what's the most likely output that should follow. So for a language model that is trained on a large data set of English books, this is what the model would respond for the given input. If you have trained your large language model on code base, then for this input, it will output the likely output this, which seems like a plausible likely output. So the thing is that these large language models are actually extremely large, so large that it's not possible to build and train them for individuals. Only a handful of organizations in the world are training them and optimizing them. And so it used to be that the natural language processing domain, it started with recurrent neural networks, and then we had LSTMs and then transformers. So small neural network architectures that normal engineers like you and me could experiment with. But they were limited, they were constrained in their capability. And LLMs, these large models, have taken away, have solved the problems that they had, but they are also coming with their own set of problems. Like training them requires, some of these models have been trained on 50,000 GPUs in parallel for months. So it's really out of hand for normal people. So usually these are the domains that the usual natural language processing tries to tackle, where we try to extract entities from a given text of input. So if you say, I am in Istanbul, so I and Istanbul are entities. If you say, I have a pet cat, cat would be an entity. So the usual NLP algorithms would be succeeding at these tasks, but they would fail 5% of the times. But the large language models are extremely good at them. So they're also tackling translation problems, classification, where you try to classify text as positive versus negative, violent versus peaceful. So do you get it? So even if you don't, if you feed this dad joke to a large language model, it can not only understand the context, but it can comprehend the logic involved and how it is a play on the word clean, so which has double meaning used in this context. So these language models have the capability to reason, provided good amount of data. And we'll talk about it. They are also good at coming up with recommendations. So you want to plan your trip, or you are looking for a recipe. And that's how they help us prototype really fast. If you are working on a script for a movie, or writing a book, you want to proofread the contents of your research paper or your university assignment, any of those type of tasks can be very efficiently achieved. Also writing email, that a lot of us are using ChatGPT for these days. But they also help us generate synthetic data for our machine learning models that we might want to train. So those of you who are students or even industry professionals who work in AI domain, sooner or later you will run into the problem of collecting matching data for your model that you are working on. So if you have very specific cases, LLMs can generate training data for you really fast. I also want to touch upon prompt engineering. One of you who has heard of it? Prompt engineering? Who would like to explain it? Come on. Okay, yes. Yeah, sure. Mm-hmm. That's one explanation. Yeah. So it's the crux of it is the art of making the LLM give you your desired output. So how you ask the question, how you frame your question, and then if you don't get the correct response, then you keep asking in different way, or making your requirement clear. So there are a couple of types of prompt engineering that have gotten popular, like zero-shot prompting, one-shot prompting, where you either provide zero example, you simply ask a question and LLM answers you. So this is what you are doing when you ask ChatGPT a question. That's usually zero-shot prompting. If you provide it with an example, for example, you ask it, Istanbul, map it to Turkey. So what should Berlin map to? And the LLM would be able to reason that Istanbul is a city in Turkey, so I probably need to respond with the name of the country when you have provided it with Berlin. So these are a few type of prompting techniques that you should know if you are trying to build a user-facing application that involves large language models. And we can use these to build a lot of consumer-facing applications like customer service. So where usually you call a company, let's say your telecom provider or your internet service provider, and complain about their service to get it fixed, or if there is a recurring issue. So a lot of those tasks are being replaced by LLM agents or bots who not only are very good at understanding the problem, but they can also go and fetch the relevant information from the dataset or documentation and respond to you. And this is what we'll see, and this is what we'll build towards today. There are also other similar applications like personal assistants. And so when we think of personal assistant, we think that only when we are a CEO of a company should we have a personal assistant, but actually now you can afford to have your own personal assistant that not only knows your preferences, but also if you want to give it access to your historical, let's say, travel records or your purchasing history, and it can give you recommendations that are not only personalized to you, but also private. So since you yourself built it, it resides on your own machine. So no big company has access to your private data, and you can be as flexible with your preferences as you like. So our goal is to build this chatbot that will be able to answer questions based on our, let's say, I write a lot of words in my diary. So today morning, I wrote that I am in Istanbul. This is the first time I'm traveling. And after the conference, I'm looking forward to exploring the city, trying out the local food. And I just wrote down a few other thoughts that what are my goals for next 3 months. So the thing that I usually write in my diary. And I have gathered about 100,000 lines of text in my diary, and if I want to make it searchable, so that what I was thinking when I visited Malaysia, or what I was thinking when I visited Italy. So those I don't have to make. If I search for Italy, it can appear at random spots. But if I attach it to this language model, it can come up with the precise information, precise relevant content, and summarize it that when I was in Italy, these were the thoughts that were going through my head, and this is what I wrote in my diary. So to achieve that, we'll first look at embeddings, and anybody who would like to take a guess what are embeddings? I know you know, some of you know at least. Yes? No, actually. So anybody else? Anyways, so embeddings are actually a number representation of your text. So imagine the text. So for example, this headline has 4 words. Replace these 4 words with a bunch of numbers, an array of numbers, and those would be embeddings at a very simple level. But in reality, these embeddings also have some sort of spatial meaning. So by spatial, I mean that if you plot them on a graph, you'll see that the entities that have sort of similar meaning would appear closer to each other. So for example, man is to a woman, but a king is to a queen. So we did not randomly assign these English words with random XY values and plotted them on the graph. Actually, these, while training, the model learned them which of the entities are closer to each other, which appear to have closer semantic meaning in the data set that they appeared, and it automatically gathered them closer to each other. So for example, a man went and bought a house, that sentence is a valid sentence. A woman went and bought a house, that's also a valid sentence. But a table went and bought a house, that would be not comprehensible. So that's why when you plot the table on this table on this graph, that would not appear closer to man or woman. It would be in its own different cluster. So this is a very simple thing. This is, I believe, the only technical thing that you need to understand about machine learning or NLP to achieve to build this search bot. By the way, can I ask any of you who have developed in Python programmers and JavaScript programmers and Java others? Okay. And those who have not raised their hands, Turkish programmers? Okay, nice. These days, if you go around on the internet or you hang on the forums where the cool engineers hang, this is the new architecture design that's that's really trendy, retrieval augmented generation, which is just a fancy word of saying that we are attaching our LLM with a database that will be our source of truth. So essentially, so anybody knows what hallucination is? Please. Exactly. So hallucination is essentially when the model gives an output that sounds plausible, but it's factually incorrect. So it's actually lying to you, but the English sentence that it outputs, or the Turkish sentence it outputs, seems to make sense. So it won't be gibberish like a 2-year-old speaks. It would make sense in a language, but it would be factually incorrect. So in order to avoid hallucination, we attach our language model with a source of truth in our case. So this is Very simple diagram, don't be afraid. So let's say this is my diary, which has many pages in which I have written thousands of words. I want to make it searchable. So I will convert it into smaller chunks of documents. So let's say we are using Google's PaLM large language model in order to build our search engine. So it has a context length limit. So which means is that it can only take, let's say, 8,000 words at a time. So our documents cannot be more than 8,000 words, one single document. So what we do is we divide document into chunks. Very simple. In Python, you can just use split at the very basic level. Then we convert those documents into embeddings. So their corresponding number representation by calling a very simple REST API of Google Cloud. And then we store those models into a database. So these days, there are some fancy vector store databases, but you can also you're also good with using MySQL, Postgres, Redis, any document database or normal database that you are comfortable with. And in order to ask the question, so let's say actually it's true that I am in Istanbul today, and I wanna search for what were my thoughts when I was in Rome. So first, what I need to do, my question is in text. I need to convert that question into embeddings as well. So I make the API call to convert those embeddings into, text into embeddings. Then I search for nearest. So we saw in this graph, we can use very simple nearest neighbor search algorithms that can give us neighbors of Ireland. So whichever entity you have, you can search for nearby neighbors very quickly. That's what we do here. So we search the vector database for similar matching documents. It returns the documents that mention Rome or Italy, and my question and these documents both are fed to the language model, and the language model, as we saw, has the ability to reason and think. And so it takes the question, and the context is the documents, and from those documents, it reads the information, summarize it, and responds with the summary of what the answer should be based on my data. So this is at a very high level overview. It's very simple. We are just splitting the document and making embedding calls. It's called retrieval augmented generation, a fancy name, but it's very simple. And let's see if we can have a quick demo. Yeah, yes, please. Okay. So this is a good question. What is the right way to chunk the documents? So there are a couple of different techniques. So let's say I have one big file with 5,000 words. So if I split it at every 1,000 word, that I can lose the context. So I can split the document where in the middle of a continuous sentence. So the last sentence would not make sense. So there are different techniques for that's why we'll use the LangChain library if I have time to show you the demo. So what happens is that it splits the document based on the context, and it doesn't split randomly. So it stays within the limit of that your large language model accepts, but it splits it in such a way that smaller chunks do not lose their context, and also it makes sure to have some overlapping text so that the last context from previous document continues in the next one. So if we do get to make this work in that, I'll be able to show you the demo. Otherwise, we can look at the previous outputs from the previous runs. So essentially, what we are doing, so LangChain, has anybody heard of LangChain? Okay, so LangChain is a framework to make it really easy to build these large language models. And all the documentation is on their website. It's extremely easy to use. But the main thing that you need to understand is, so we have imported Vertex AI object from their library. And here we are declaring which large language model we want to use. Text Bison comes from Google. And it is like GPT-4. Temperature, top key, I'm sure you are aware of it. So I can share this. Unfortunately, my time is up. So it will take some time for the demo to run. I can share it with you. And so just want to show this part. So for example, you can set the context. So you might have done this in ChatGPT as well. You ask the model to act in a certain way. So here we are asking it to act like my assistant in a space travel. And it should respond in the similar way. And this is the main part here. So we split, the text splitter comes with the split that splits the document, and then we retrieve embeddings on those documents. These are very simple single function API calls, and you store them in your database, and then you use the retrieval QA object to retrieve questions from the query, from your document. So in this case, I am asking it to tell a joke, but from the file that I specified here. So obviously, I'm not going to show you my personal diary. So these are the jokes. So if you are familiar with programming, it will be very easy to understand if you want to go through this notebook. And I would say go here. And also, do contact me on LinkedIn. If you have any questions, I'm here and I'm outside. I'm Emad Ehsan, and thank you for listening.